Hello everybody and welcome to my talk, Bypassing Windows Hello for Business and Pleasure. My name is Omer Tsarfati. I'm a security researcher at CyberArk Labs. I'm 24 years old and I'm for 6 years in the security industry. And for those of you who play Call of Duty, I'm a big Call of Duty fan, so feel free to contact me and we'll play together. So what will we have today? We'll talk a little bit about Passwordless. What is Passwordless? Why should we use Passwordless instead of existing authentication methods? Then we'll speak about Windows Hello, which is the relatively new Microsoft passwordless solution. And then we'll talk about the main part of this research that we did and on how we managed to bypass Windows Hello facial recognition. At the end, we'll talk about what could be done even furthermore in the research. And for any of you that would like to continue this research, is more than welcome to look at this part very closely. Anyway, by the end of this talk, you should know by 85% what Windows Hello is and some of its features, by 50% about USB and UVC, by 10% you should be a little bit confused and you should have a lot of fun. Right? Let's go. Let's start. Let's talk about Passwordless. So what is Passwordless? So Passwordless, it's kind of... All right, so before we're talking about Passwordless, let's talk why we should use Passwordless. I mean, we have existing authentication methods. We have passwords. We're using those for years, and why we should replace them. So underneath passwords, there is a lot of problems inherent. I mean, we're human, and we tend to use weak passwords because we want to choose password that is really easy to remember. There are data breaches. So once we're giving a vendor or a server our password, it should save it somewhere in database or something like this. In some cases, it saves as a hash version of our password, and in some other less good cases, it saves as plain text. And once hackers or attackers breach in and steal those passwords, they might get our password, so it's really bad. And the third thing, it's phishing attacks. So phishing attacks, it's a major problem because we are human and we tend to fall to them. We tend to give our passwords on our will to attackers and hackers, and so this is another big problem. And as I mentioned before, we are human, and we don't want to remember a lot of things. So we will use passwords and actually do this. So we reuse our passwords for many vendors, and if one of them got breached, we actually lose all of our accounts. So now we understand that passwords are kind of not that good as we thought. So let's use Passwordless. So what is Passwordless? So how you should do Passwordless? So Passwordless is any authentication method that doesn't really require you to send a password. So like fingerprint scanning or facial recognition, security key or OTP, all of those are variants of Passwordless solutions. About OTP. So OTP, it's kind of one-time passwords, and it might not sound as a passwordless solution, but because it's one-time passwords and you can only use it one time, it's considered as passwordless solution. So now we understand that passwords are bad. What is passwordless? How passwordless solution implemented in different ways. So let's talk about one of the most common implementation of passwordless, which is Windows Hello. As I mentioned before, Windows Hello, it's Microsoft's relatively new passwordless solution. So say hello to Windows Hello. Right, so Windows Hello is for everyone. Everyone can use it, either if you're enterprise or home consumer. The main difference between those implementation, it's their main purpose. So for enterprise solutions, it will give you the ability to authenticate via domain or Azure assets. And for home consumer, it's actually kind of replacing your passwords. It's not actually what's happening in the background because your password hash is it still remain on your device, but your PIN code will let you access it. The system will access it, and then you can still use it. All right, so let's talk about Windows Hello features. So Windows Hello has three main features: face recognition, which rely on IR sensor and advanced analysis of the frames that come in from the IR sensor; PIN code, which is kind of replacing your password with another password, local password; and fingerprint scanning authentication, which we all know for years. Right, so we wanted to do a research on Windows Hello because it's passwordless, it's cool, and we thought which feature should we do a research on. So we did a little overview on all the solutions, on all the different features. And we try to consider what will be the best option to do research on. Fingerprint. So to collect the data, the fingerprint scanning images itself will be really hard. Besides that, there is a lot of previous art on this area. I mean, I think in 2006 in Black Hat there was a research on this. There was a talk on this, and the protocol is kind of hard to implement, and there is not a lot of public implementation for this. PIN code. So PIN code has anti-brute force mechanism, so we couldn't really do a brute force on this, and we thought it will be the same challenge as trying to break your regular passwords for the computer. So we didn't want to choose this as well. And so the third feature that we did an overview on, which is the last one, it's face recognition. So face recognition also has anti-brute force mechanism. It is more easy to start doing a research on this because NXP, which is a major vendor in the electronic industry, implemented a basic USB device, which you could use as a reference. And your face, at the end of the day, it's kind of a public data. I mean, we can capture this relatively easily. So we choose to do a research on this. And then we try to figure out how we should do the research. I mean, we should first understand how biometric authentication in Windows actually happens in the kind of an overview. So we are starting from application or credential provider that want to do authentication and biometric authentication. Then it uses WinBioDLL that at the background will communicate with the Windows Biometric Service to do this biometric authentication. The biometric authentication is divided into three parts. I mean, the facial recognition is divided into three parts: the storage adapter, engine adapter, and sensor adapter. The storage adapter will get the information, the biometric templates that are saved on your device from the Windows Biometric Database, which is a folder in System32, which contains many different databases for different authentications, and facial recognition has its own database there. And there is another adapter, sensor adapter, that is actually responsible for communicating with the external camera, IR sensor. And there is the engine adapter. The engine adapter is the one that responsible for deciding either to log you in or not. Right? So after we created this graph, we look at it and we thought what would be the best place to do the research on. I mean, we don't have any kind of code execution on the device, so most of the parts are not relevant. And the only part that we kind of can control, it's the sensor. So we consider the following things. So at first we thought that it will be cool to run code on the sensor itself, but actually it will be a standalone research for itself, and we didn't want to go there. And the other way is to be the sensor. So we implemented a kind of a IR camera out of nothing. We used NXP evaluation board for this, and we will talk later why we use this. And one of the main reasons you actually use this is because as I mentioned before, there is an example project which we could use as a reference. So it will be much more convenient for us to actually use NXP. Right, so we talk about Windows Hello, about Passwordless, about what we want to do in the research. So let's talk about the research. So part 3, exploiting, show me the money. So the research vector is divided into 4 parts. The first one will be analyze. Before we try to implement a USB device, we first want to to understand what USB and UVC is. Then after this, we will mimic the USB device, which actually we will create kind of a low camera, USB video camera that is compatible with Windows Hello and can function as a regular Windows Hello camera. Then we will capture the person that we put as a target for us to log into his account and bypass Windows Hello authentication, and we will bypass Windows Hello. All right, so let's talk about the first part, the analyze. So the analyze section is divided to 2 main parts. At first, we need to understand the USB specs, and then we will need to capture the traffic. And so capturing traffic we will do it via Wireshark with the plugin USB pickup. And the USB specs, the way that we chose to do the research to understand the USB spec is to read the USB spec. And we read it, we read a lot, too much, and we went to offsites. I mean, it's too many. And I thought what would be the best way to explain to you guys, for those of you who are not familiar with USB and UVC, the USB specs, at least the USB framework. So we choose to do it in a kind of story. So this is USB. USB, it's a nice guy. And it's USB first day at school. So he went to school and then he met Austin. And Austin, it's a bully. And our USB is a nice guy. And Austin came to USB and asked him, who the hell are you? And the USB told him, I will say everything that you want to know. Let me do it in a great detail. So because he was afraid of Austin that he will beat him up, he considered what would be the best day to do this. So the best day for him to do this was via descriptors. So he started to describe himself. At first, he started with device descriptor. And where he's coming from, every descriptor has a lot of fields. And most of them are not really interesting. But the most interesting fields are the BCD USB, which is the version of the USB device, and those three fields, which is ID vendor, ID product, and BCD device. ID vendor, it's the ID of the vendor, ID product, the ID of the product, and the BCD device is the version of the device. Right, so besides that, Mr. Nice Guy wants to tell about his abilities and features to Austin because, again, he's really terrified that Austin will beat him up. And he started to do it via configuration descriptor. So he sent a configuration descriptor to Austin. And Austin, Austin needs to allocate enough memory for the descriptor. And because every USB device is a bit different from one another, the full configuration device, which describes all the abilities and features of the USB device, it's a bit different. So therefore, the length of the configuration descriptor will be either longer or shorter. And Austin should know how much memory to allocate. So at first, we are sending an intro. Intro includes the total length of the configuration. And USB device send it to Austin, and Austin now want to know what is the full abilities of the USB device. The USB device send it to Austin. All right, so I hope you understood what are configuration descriptor and device descriptor are. And this was our story about USB Mr. Nice Guy. And all right, so after we captured all this information, We saved it for later use because we want to mimic the USB device and we want to send all this metadata to the host as we were the original camera device. Right. So for any of you that want even to learn more about USB, the best way to do this is either by reading the USB specs, which you can find in the USB-IF website, or either you read it in Beyond Logic website. There is a good article called USB in a Nutshell, so you totally should take a look on this. Right. So now we finished the first part, which is analyze USB and UVC, and now let's go to the mimic part. So also this part will be divided into two. The first one will be implementing the USB camera with our evaluation board device, using the reference that NXP implemented. And the second part will be make the USB device that we just created compatible with Windows 11. Right, so this process will look like this. At first, we'll download the NXP IDE, which is called MCU Espresso. Then we'll import the SDK example, which is called the video virtual camera VM. And then we'll need to configure the example project to match the descriptor that we extracted, add another support for a second camera, as the Windows 11 requires every compatible camera to have regular camera and infrared camera. And we did all of this, so we actually should have a working and functional Windows 11 compatible camera. But once we connected it to the computer, we got this beautiful error message that says our USB device could not be recognized, and you should go and figure why, because it's not that easy to understand, as it's kind of a generic error message. So we were clueless at this point. We didn't know why it happened, because during the development of the video camera, the evaluation board, all the changes we did on the evaluation board, we didn't have any kind of these error messages. And this error message only came up when we changed one field, which was the USB version. We changed it from 2.0 to 2.1, which for matching the USB version that the original camera, the compatible Windows 11 camera, is using. And then we didn't know why does it happen, and we wanted to understand. So after a lot of trial and error, we find out that we are missing a descriptor. So which descriptor are we missing? The BOS descriptor, of course. Apparently, every USB device that reports a BCD USB, which is over 2.0 or 0x200, will be required to provide a BOS descriptor. So the operation system will ask for the BOS descriptor. And if the request fails, it means that we are not sending the BOS descriptor. The driver stack will fail enumeration of our device. And it's kind of bad. So we went through the documentation of USB, and we found out what are the fields that the BOS descriptor need to be there, and we extracted the BOS descriptor that the original camera is using, and we still remain with the same question: why did we not see the BOS descriptor in the Wireshark traffic captured? I mean, we capture. It should show all the information, all the traffic, but it's missing the BOS descriptor. So we thought why it is happening. So the main reason for this is because we didn't use Linux, and we didn't understand why there is those differences between Linux and Windows in capturing USB devices, because we didn't really do any kind of a research or a further investigation on this, but it was really strange to find out that this is the main reason. Anyway, after this, after we added the BOS descriptor to the USB device, and we added implementation for this, we connected the USB device, and then we got this. So now we have a fully working USB video camera that is compatible with Windows Hello, and we can control all the information it's sending to the computer. So what are we missing? We're missing the information that we need to send. So let's capture it. All right, so as I mentioned before, Windows Hello requires you to have a IR sensor which will transmit infrared frames and camera sense and the color camera sensor that will transmit regular camera, color frames. So we need to capture both of those. And a funny side note about that, doesn't really pay attention to anything that you are sending in the color frames, because the analysis mechanism, it's only relying on the infrared frames. So you actually can send whatever you want there. We chose, by the way, to send frames of SpongeBob, and believe it or not, it worked. The other frames were real, by the way. So if we want to capture the data, let's talk about how the frames are transferred to the computer. So now we see the URB packets, USB URB packets, which kind of reminding how UDP works, as it's sending chunks of data, kind of streaming the video to the computer, and the computer needs to extract the information from this. All right. So how does the computer know what is the start of the frame, what is the end of the frame, what it should do with the frame? So each frame starting with an header, with the header. So this header is has a lot of fields, and we are not really want to go all over them, but two fields are really important for us: the frame identifier and the end of frame. So the frame identifier tells us when a frame is started, and the end of frame, as it sounds, indicates us when a frame is ended. So with this information, we could go over a USB traffic of a video stream, look for the URB packets, and extract all the frames. But because we know where the frame is started and where it's ended. But to validate that our frames are valid at the end of the day, this is what we want to do. We need to know in which format they are being sent. So we looked at the configuration descriptor because it's mentioned there, and we look at the color image, and we saw that this is kind of MJPEG frames, the stream of MJPEGs, and the left one, which is the IR sensor, is the strained GUID. So we didn't know what this strained GUID means, and so after a lot of Googling, we found out that this is KS data format subtype L8IR, which is a format that Microsoft uses, which is at the end of the day, it's Luma 8-bit plain frames. By the way, we could save a lot of time of Googling if you look just straight in the MSDN documentation, because it's written there pretty much straightforward. So by now we covered USB and USB specs. We know how to capture USB traffic. We managed to implement a fully working video USB device, and also we know how to extract the video frames. So we have all of the information that we need with all the tools that we need to bypass the authentication. Right, so what I thought that it will be really great to go with PyShark, which is a library in Python for manipulating and loading Wireshark traffic capture. So go with PyShark on the capture, save the relevant frames with the previous knowledge that we have, and save it into the evaluation board, send it to the computer, pretending to be a real USB Windows Hello camera, and bypass the login, the facial recognition. But it didn't work. So the reason it didn't work, it's quite interesting. Apparently, the regular camera sending a lot of information and a lot of frames that are not valid, which was really strange, but apparently Microsoft knows how to get rid of those frames. And we didn't want to understand how to do this, as Microsoft did it already. So we used Microsoft made a framework to capture the relevant infrared image frames of our target person, saved it into the evaluation board, and it worked. This time there was a lot of yay in the crowd, and it was really, really fun. Right, so we talked a lot. Let's see the demo. So it's demo time. Right, so here we see Windows Hello user. This is the evaluation board that we used. It's a custom USB camera that stores the recorded iframes of me, of course. We connected it to the computer, of course. And shortly, Windows will recognize the USB device and will use it as it was a regular video camera. Windows Hello compatible, by the way. So the custom USB camera sends the recorded frame to the target to the computer. So this actually tricks Windows Hello to think the target person is in front of the computer, and proof. All right. So let's discuss what we just saw. All right, so at first the attacker captures or creates an infrared frames of the victim. Then it stores the infrared, he needs to create a custom USB device that impersonates a USB video camera that is compatible, of course, with Windows Hello. The attacker saves the relevant information he captured in the first step to the USB device. Then he connects the USB device to John's computer. The USB device transmits the capture infrared. The biometric system accepts the biometric credential and logs the user in, and the attacker gets a lot of information and sensitive data that he shouldn't have access to. Right. So here we come to the final part. This is the fourth part. What we should do in this research even more. Right. So, what I recommend you to do if you want to continue this research is to find a way to convert color image to infrared. So if you will do a Google on this, you will find out a couple threads in some forums that will say it's impossible. But we actually did quite briefly research on this, and we found out that from our research, it might be possible because we managed to convert one color image of me to infrared one, but it wasn't that extensive research, and we do recommend you to do a better research on this. Another really interesting thing is to manipulate the biometric database in Windows. At the end of the day, if an attacker wants to create really smart backdoor that nobody will look after, he should look at this. I mean, it is considered to be a place that you save a credential in, and if somebody is able to manipulate this, it will be great, and it will can create a passwordless, a backdoor to the user account. The database, at least the one that Windows Hello uses, it's protected by the system passwords, but I think that if the attacker has already high privileges in the victim computer, he can manipulate this. Another cool thing will be fuzzing. So if an attacker could extract this database and decrypt this with a system password and take all the information there to a local machine and start to use the Windows Hello framework in order to kind of fuzzing the database to find out what will be the relevant information it will be able to send to a real device to unlock the device target, it will be really interesting. We started also to do a small project on this, and it's a work in progress. So if anything will come out from this, we'll let you know, guys. And that's for what is next. So let's cover what we saw today. So at the first section, we talked about USB. Then we went about passwordless and what is passwordless, why it's considered to be more secure than regular traditional authentication methods, or in other way to say it, passwords. So we talked about Windows Hello and how we managed to bypass Windows Hello, what considered to be the weak point, the weakest point in the Windows Hello mechanism, and the fourth thing that I hope you had, it's a lot of fun. So regarding recommendations, so this attack vector is not even about Windows Hello specific. It's about authentication mechanism that rely on public data, public factor for authentication. So please don't base your authentication on public factors. About mitigations. So we worked alongside Microsoft to mitigate this attack vector, and we're still working with them on this. And Microsoft told us that they should publish advisory to mitigate this attack vector. So by the time you will see by the time you're seeing this video, this talk, there should be advisory in the MSLC website. So go and check this. And besides that, we also, by the time you're seeing this this video, we also published 2 blog posts about this research and what we did in the research, even more extensive than this talk. So feel free to visit our website, our threat research blog. So thank you very much, guys. I am Omer Tsarfati. I had a great time being here today, and feel free to contact me via Twitter if you have any questions. Besides, I'm waiting for your question in the live Q&A. Thank you very much, guys.